All right, I'm going to do problem 12 from chapter 11. It encompasses several of the topics that we've covered. And chapter 12 talks about two organic emu ranchers. So I think that's sufficiently cutesy. And their names are Bill and Ted. And what we're told is that we're told that the demand is 150 minus P for the market. And that means that the inverse market demand is 150 minus Q. We're told that Bill has a marginal cost of $10 and Ted has a marginal cost of $20. And part A asks us to treat them as Cournot duopolists and define price, quantity, profit, and consumer surplus for each. So part A says this. So we'll take each of them separately. I'll put Bill over on this side, and we'll put Ted over here. So Bill's demand is going to be 150 minus QT minus QB. Right? And his marginal revenue then is going to be 150 minus QT minus 2QB. And we'll find his reaction function by setting marginal revenue equal to marginal cost. And so we'll say 10 is 150 minus QT minus 2QB. This is Bill's problem, so we want to solve for QB. So I'll get 2QB is equal to 140 minus QT, or QB equals 140 minus QT over 2. That's Bill's reaction function. Ted's reaction function, we follow the same procedure. Write down his demand, which is 150 minus QB minus QT. His marginal revenue then is 150 minus QB minus 2QT. Set marginal revenue equal to marginal cost. We get 20 equals 150 minus QB minus 2QT. And now solve for QT. So we'll get 2QT equals 130 minus QB. And QT then is equal to 130 minus QB over 2. And those are the two firms' reaction functions. What we want to figure out is where the two intersect. So we need to solve them simultaneously. And I'm going to do that just by substituting QT in here in firm B's, in Bill's reaction function. So that's going to make Bill's reaction function equal to 140 over 2 is 70 minus 1/2 of QT, which is 130 minus QB over 2. And so now we've got this down to one unknown, and we just need to solve. So this is going to be 70 minus 130 over 2 is 165. And that divided by 2 is 32.5. Plus, we have the two minuses, plus 1/4 of QB over 4. That's all equal to QB. And so take that to this side. We get 3 QB over 4 is equal to 37.5. Solving for QB, we get QB is equal to 50. Now we go back to the other reaction function. We can say QT is equal to 130 minus 50 over 2. And so that's just 80 over 2, which is 40. So Bill produces 50 units, Ted produces 40 units. What's the price going to be? Well, price is 150 minus the total quantity minus QB plus QT. And so that's going to be 150 minus 90. So price is equal to $60. How much does each earn in profit? Bill's profit is going to be price times quantity. Price times quantity, so that's 60 times 50, minus average cost, 10 times quantity, 10 times 50, and that's 2,500. Ted's profit is going to be price, 60 times quantity, minus his cost, average cost per unit, times quantity, and that's going to be 1,600. Okay. And finally, we want to find the consumer surplus. So I like to do this by drawing a picture. I think it's the easiest way to do it. My demand curve has an intercept of 150. And in this case, we have a price of 60, quantity demanded of 90. And so the consumer surplus is this rectangle. I'm sorry, this triangle, which is going to be 90 units high, 90 across. So 90 times 90 is 8,100. Half of that is 4,050. And that's the consumer surplus for this Cournot duopoly. Okay. Part B asks this. It says, oops, sorry about that. Part B says, suppose they merge and become a monopoly, and suppose they both adopt Bill's production. So they each have a marginal cost of 10. In that case, what's the price, quantity, profit, and consumer surplus? So let's see. So part B, we say price is 150 minus Q, and we're going to make the marginal cost 10 for all units. And so this is just a standard monopoly pricing problem. Marginal revenue is 150 minus 2Q. Set that equal to marginal cost. So 10 is equal to 150 minus 2Q. So 2Q is equal to 140. That makes the quantity 70 units. And the price then is 150 minus 70, which is $80. What's the profit for this firm? The monopoly profit is going to be price times quantity, 80 times 70, minus marginal cost, 10, which is also average cost times quantity. And so that's $4,900. What's the consumer surplus in this case? Well, again, we have our demand curve. Now, the price is 80, and the quantity demanded is 70. So now the consumer surplus is equal to 70 times a half. So that's 4,900, and half of that is 2,450. Okay. Part C says, suppose that instead of merging, Bill considers buying Ted's operation. How much should he be willing to offer for Ted's operation? So how much would Bill be willing to pay for Ted's firm? Well, under Cournot, Bill's profit we found to be $2,500. And under monopoly, which is what would happen if he bought out the other firm, then he would have a monopoly. Under monopoly, the profit is $4,900. And so that's how much he stands to gain by getting rid of a competitor. And so his maximum willingness to pay should be $2,400, the amount that he stands to gain by becoming a monopoly. Part D says, or asks the question, has the combination of the two ranges discussed above been good for society or bad for society? So let's look at two things here. We could look at Der Corno versus monopoly. What has happened to consumer surplus? And so consumer surplus under Corno was 4,050, and under monopoly, it's 2,450. So clearly consumer surplus is much lower. Oops. What about profitability? Under Corno, the two firms together earned a profit of $4,100. And under monopoly, the profit is $4,900. So the change in consumer surplus is, what is that, $1,600. It's a reduction of $1,600 in consumer surplus and an addition of $800 in profit. And profit really can stand in for producer surplus in this case. And so it looks like society is much worse off. The firms are doing better. The supply side of the market is doing better, but consumers are much worse off. And it more than offsets the gain to the firms. So society is worse off under monopoly than under Corno, which shouldn't be a big surprise. All right.